Good afternoon, everyone. Welcome to Razorleaf's third Digital Thread webinar series. My name is Julianne Grant. I'm the Vice President of Marketing here at Razorleaf. Really happy to have you join us here today. Our webinar today is about strengthening your digital thread with MBE, which stands for Model-Based Enterprise. And we're really happy to bring this content to you today. So a couple of housekeeping notes is that we are recording this webinar, and we will be providing that recording to everyone who registered for this event. And also, if you have any questions, please enter them in the questions panel in the GoToWebinar that you have on your desktop, as we will be answering those questions at the end of this presentation. If there's anything that needs to be answered urgently, I'll try to interrupt Jonathan, but we have a lot of content to get through today. We want to make sure we do a good job and present the material we have planned. Okay, with that, I'm going to introduce our speakers today. We have Derek Neiding, who's going to facilitate the discussion today. He's our engagement director and has been with Razorleaf since the very beginning the organization was founded. And Jonathan Scott, he's our chief architect, and many of you have been participating in the previous webinars, and so we look forward to hearing what the presentation is today. Okay, I'm going to hand it over to Derek.
All right, thank you so much, Julianne. Welcome, everyone. We thank you for coming. As Julianne mentioned, this is a webinar that's in a series. This is actually the third webinar in our series. The first two webinars hopefully kind of laid the foundation, set the stage, provided some definition for some of the things we're going to talk about. We're hoping that this webinar helps us to kind of bring things home and start to see the value, the business application of some of the things that we talked about. We want to kind of establish what is really the meaning of model-based enterprise. What's it mean for you? How do you do it? How do you use the PLM systems that we represent to help to automate that MBE data set? What are some of the benefits that you get as you start to get out of the current state into this MBE state? What scenarios might we be able to talk about that help you to appreciate the value? And also then finally, what's the business value? What's the benefit that you're going to achieve? That's really the goals of what we want to talk about today. So our agenda looks like this. We're going to have Jonathan talk to us a little bit about a bit of a review. So some of those first couple webinars, what are some of the things that we learned there? We'll use that as a bit of a foundation. And then, introduce the model-based enterprise. What are some of the concepts about model-based enterprise? What does it really mean? How do you get there? How do you move from an enterprise that's really based on documents to an enterprise that's based on data? What are some of those examples, the benefits of doing that, and then the strategy. So we'll wrap it up by talking about, how do you do these things that we're about to talk about. So I want to introduce Jonathan to the conversation and have him start to walk us through this. And so I want to start, Jonathan, by kind of just planting a question and have you help us to understand a little bit more about that digital thread. So can you tell us a little bit more about, how we define digital thread, what digital thread means to us, what it should mean to those that are listening?
Yeah, Derek. Yeah, good afternoon, everyone. That's a great place to start, right? To talk about what is digital thread and just make sure we're all level set, at least from our side, on what we mean by that. And I'll put up this simple definition, I think, and I want to talk about it and then work it kind of from the bottom up here. So our definition is that a digital thread is a set of connected records of the data and activities which define a product. And working that from the bottom up, the first thing is which define a product, right? And that's about honing in on where it is in your enterprise, right? I'm assuming everyone that's on the webinar today is interested because they're making a product or servicing a product or somehow involved in a product, but your whole business isn't necessarily focused on that. You've got other parts of your business. You've got finance pieces and you've got HR pieces and things like that. So within your organization, the digital thread isn't all encompassing, but it is as it relates to your product. So if it's related to the definition of a product, that could be part of the digital thread. So working our way up from that third line up to the second line, the data and activities. So what's important here is a lot of people automatically think of the data related to a product as being part of the digital thread, but they don't always think of the activities. So the workflows, the approvals, the project tasks, the research, the things that go into defining the product, not just the result of those activities. So it's the data and the activities. It's what you define about your product, but it's how you got there also that's part of the context that's important. So the first part of this definition on the first line is it's a set of connected records. That's what makes it a thread, the fact that you are connecting all of these valuable data points about the product. What did we research? What did we find? What did we then decide the product needed to look like to meet that research? What did we test? How did we check? What were the design decisions we made? All those pieces are the data and the activities, but they've got to be connected. If they're not connected, they're less valuable. So when you know what decision led you to a particular design or a particular revision of a design, that's where you get some value out of this thread of having everything connected. So that's how we define it. Yeah, go ahead, Derek.
Yeah, let me interrupt you, Jonathan, because you used a key word there. You talked about value, and that's what I'd like to hear a little bit more about. So we know what it is. What is the value? So you've got this stuff connected. What do I get out of that?
Yeah, and I think that's important to talk about, is not just what is it, but why, and some of the benefits that you can get. There are probably other benefits, and I know every industry is a little bit different in terms of what their digital thread looks like and the value they get out of it. But there are three benefits of the digital thread I see that come up again and again. So decision support. Let me give you an example. Contrast what life is like with and without a digital thread. Imagine being a new engineering manager working on a product that's 10 years old, say. And the market was analyzed before that product was introduced. It's been updated and updated every other year of its life. And there's roughly 200 engineering changes associated with this product. And the assembly drawing of it is at revision P, right? So that kind of history. And the VP wants to know if we kill this product and introduce a new one, or if we upgrade it one more time. So you're that brand new engineering manager. Put yourself in his shoes. Being able to trace the history of all of that is invaluable in that situation, right? He doesn't want to say, if I'd only known this, I would have given my VP that answer. That the new guy walking in the door wants to be able to have access to this digital thread to answer those kinds of questions. Another value that's important is automation. So let me give you a simple example for this one. Coming from the mechanical world, I know a number of customers who use spreadsheets to do sizing calculations for their products, and they generate key parameters out of those spreadsheets to feed into their CAD models. With those couple of key parameters, they're able to drive the models and the drawings that their CAD system creates with some design automation tools, macros, knowledge templates, that kind of thing. And once they have their CAD tool automated, though, the next logical step to them is to extend that automation. That's where the digital thread comes in to support that, right? So if you can connect those spreadsheets that they used up front to get the key parameters to the CAD models, and you know which versions go with which and for which customer and which project, then you can wire up even more automation. You could even get fancy and loop through the process until certain design goals are met, like weight or balance or things like that. And that leads to automated optimization, not just automatically generating the design deliverables. So having the digital thread connecting useful pieces of information can get you some automation benefit as well. Let me throw one more out there, forensics. So it's been a few years since counterfeit products were the top news items, but if you think back several years ago, there were several of those cases in the news. But the manufacturers in those news stories were in the hot seat because of unexpected materials in their product, or poor quality components being used, or worse, dangerous components, like if you remember the one about lead paint in children's toys. A digital thread can help companies quickly answer questions when something like this happens. And speed is everything in a PR crisis like that. So just as importantly, though, is how the digital thread can help before the crisis happens and the organization is trying to prevent the crisis, right? Or prevent it from being a big news story. So like when we find a problem in a certain manufacturing plant or a supplier, can we quickly trace and track the usage, the impacts, the driving decisions, and other pieces of product information that'll help us contain or prevent this from being a full-blown crisis? You know, when something like this happens, it's too late to build a digital thread then, but you sure are glad if you have one if you ever need it. So yeah, there are probably more than this, but these are a couple, right?
That makes a lot of sense, Jonathan. I appreciate the practical application of that. So let's transition then to the focus of our conversation today and talk about model-based enterprise. So let's define that and then get into how we're going to use that model-based enterprise to make a stronger digital thread.
Yeah, so let's jump into that by talking about what's a model first, right? A model-based enterprise, we should grow into that definition and how we see it, but let's first talk about models. It's easy to think of a model as a 3D mechanical model, like what's on the screen, and that's not wrong. That's certainly a model, but there are many other types of models, including math models, state machine models, behavioral models, and many more. So that's the first thing that's important, is let's make sure when we say model, we're thinking broadly enough. In fact, when we're thinking about models, it's important to remember that you can have multiple models for a single component or element of a product, like a motor. There are design specification models for making the motor, the gray one on the top left there. There are behavioral models for analyzing the thermal characteristics of the motor when it's running. There are marketing models like the blue one on the top right, that's a rendering of the product to help sell it. There are logical models like what's on the bottom left for planning the motor's function within a system and how it behaves. And on, right? I've got others on the screen too, but the point is there are multiple model disciplines and domains, as well as different levels of model fidelity. That's another piece that's important, right? Sometimes your model's really simple and just gives you kind of the basic, voltage and current in equals rotation out. But then there are actually equations with differential equations that describe the actual velocity of that shaft. So different fidelity of models can matter too. And what that means, and I hinted this earlier, is that different models are useful for different industries, different companies, and it all depends on the usage. What do you need the model for? You need different model fidelity at different times during the design. So there is no one perfect model. There's no one perfect approach, but there are lots of models, and sometimes you need many of them just for some of your basic activities. So that brings us to talking about MBE. Now that we've talked about what models are, let's talk about how the enterprise can use them. And lots of people have different views of the model-based enterprise, but this is the way we see it at Razorleaf, this sort of picture of the domains. There are multiple domains that apply throughout the life of a product and different types of models within those domains. And I think this is a good view of things when strategizing about how to transform your business through the use of models. I'm not going to read all of this, but I think everybody gets the idea of how these different domains can combine and they come together to make up the overall life of the product. But now that we've defined MBE, let's get right back into the practical application of models and how they can strengthen the digital thread.
Yeah, Jonathan, this chart is interesting. It really does tie a lot of things together, and I think it helps to see how an organization might work together. I do want to challenge one thing on it, and that is I wonder if some would argue that everywhere that we've got the word model-based, you could just put the word PLM. I mean, isn't this really what we've been talking about PLM systems for the last 20 years, and we've just swapped out the word PLM with model-based? Is model-based really different?
Yeah, that's a great point. I mean, I think in some ways you can view it as that. You could say, well, isn't the life of a product systems engineering, then engineering, design, manufacturing, quality, and sustainment? And that is, right? So let's dig into that for a minute. How is model-based really different from what came before, or even for a lot of people, what they're doing now? Let's, for the sake of argument and clarifying this point, let's just say that what comes before model-based is the drawing-centric world. And let's take this example. So if you're making a product, everyone has a manufacturing drawing so that they can forge, stamp, machine, print, or whatever, however they're making it. But for companies whose product goes into someone else's product or building or plant or whatever, they need to communicate certain things about the product to that customer, but without sharing all of the manufacturing details, right? We wouldn't share the kind of drawing that's on the screen with our customer necessarily. I have a lot of customers who do this through a separate sales drawing. Similarly, I've got a lot of customers with complex supply chains where other manufacturers make their components, right? So not only are they selling their piece to somebody, but they're buying the pieces of the thing they put together. And many of those folks also create drawings on the other side, inspection drawings, to identify the critical details that they check when receiving materials. So we can see that sort of depending on the usage, there may be different drawings, different views of things that are important to different stakeholders. The problem here is when something changes, it can take a while for everything to get updated the way it needs to be updated. And things often go wrong in that process. Even with sort of watertight processes and tools, you know, PDM, PLM, things like that, it's still a challenge because we've got several different pieces of data that represent views of the product or a component. So what changes with model-based approaches, it's different from this drawing-centric approach, is with model-based approaches, people start to work with shared data. They create and use a model that works for multiple purposes, not creating purpose-built drawings for an individual or a department's needs. Now you have to control that carefully, but this is one of the key differences of model-based approaches. So you go from this to this. Now, I'm oversimplifying to make the point, but this is the idea. The one shared model makes a lot of processes leaner, right? So instead of each person looking at the drawing that they need on the right to pull the information that they need at the time they need it, they're all looking at this one model on the left to pull the information they need when they need it. And you can imagine that things like changing this information are a lot simpler when it's just one model. Changing a dimension on that product still requires buy-in from everybody, right? So I'm not talking about a wholesale change. It's not like now engineering just gets to decide, and sales or quality or folks don't have to have some say in the matter about changing the product. But when they all agree it's time to change the product, they do it on the shared model, and boom, it's done. It's done once, everybody agrees, and now it's available everywhere. So it's a much leaner process, much less error prone. But let me take this a step further, because that's not enough value for to justify going model based. It's nice and it's an improvement, but there's more to it than this. So let me take a step further and let's take a look at how this concept of model sharing has evolved into something very sophisticated. Here's a model like the one we just talked about, being shared across sales, manufacturing, and inspection, right? I've got 3D and I've got annotations on top of that 3D. What's different about this model is that it includes information that can be shared by humans and machines. So that's something I didn't touch on a minute ago. So this model sharing is not just about sharing across departments, but sharing with people, with machines also. Let me take you through the example of what I mean by that. So the dimensions and tolerances on this model communicate some very specific characteristics about the component. This is model-based design or model-based definition. For instance, you see I've highlighted 𝙤𝙀 there. That's telling us use that shaft as 𝙤𝙀. This next piece of tolerancing information says hold the cylindricity on the inner hub very tightly. And this piece tells us to hold the size on the hub diameter very tightly. And this last piece tells us to use that hub diameter as another datum. So all of that dimension and tolerance information is capturing some intent and some knowledge in that model. Okay, interesting enough, but when that model and that information is shared with CNC programming machines, the computer can interpret the model and automate how the part gets made. So rather than creating a drawing from the design model and then asking a manufacturing engineer to interpret it, to do the programming in the machine tool, we're sharing the model and reusing this information. So I've got the details there in the steps about how does that machine interpret this, right? Turn it, don't mill it. Hold the workpiece in a certain way. Operate within a specific speed range when you're doing the turning. You're going to need to make a tool change every n number of cycles. Those are the kinds of things that this other machine can get out of having shared the model and understanding the intent that was baked into it. But we don't get this benefit just once. The same original design model can be used as input to the coordinate measuring machine, CMM machine, that will inspect the component. This is where model sharing really starts to benefit the enterprise. It isn't just helping one group talk with another, right? So it's not just an engineering to manufacturing, hey, it's faster for them to talk. It's getting multiple groups to work from the same shared data set to really read off of the same sheet of music. And what better way to align people to be doing the same thing and to reduce inefficiency and reduce waste than to have everybody working off the same sheet of music. So anyway, I'm belaboring it, Derek. I think we've covered MBE in enough detail, maybe too much detail for today. So let's switch over, if it's okay, and talk about how MBE and digital thread fit together and how model-based concepts can strengthen the digital thread that we talked about initially.
Yep.
Sorry, I just needed to take a second to take a sip of water there. So yeah, jumping into that, let's go back to the digital thread. I want to talk about a practical, simplified digital thread here, and that's what's on the screen. The gray in the background is my thread. It's connecting lots of pieces of data, and this is kind of the document-based world or the drawing-based world, where on the far left, my Excel icon is maybe that's a set of requirements that I captured in an Excel spreadsheet. And then I've got some basic calculations I do in MATLAB or MathCAD or something like that. And perhaps there's a report and a write-up, some decisions in a document. Then maybe I've got a project plan that's going to describe how we're going to go through the development steps and which sub-assemblies and components in which order. And there could be other things in here, solid models, drawings, reports, whatever. What I have at the end, right, you see is an analysis model, right? Some thermal analysis, maybe I'm making something that's got a battery pack and power requirements, that kind of thing. And so I've got to check the heat on that. But that's my digital thread, right? Is from the requirements at the beginning all the way till I'm analyzing them at the end. I've kind of connected the dots and lots of formats, lots of files, documents, reports, whatever, but they're all connected in a thread. So how do I make that better, right? How do I strengthen that? And what I'm proposing here is that by making it model-based, we're going to really make some improvements. We're going to make some things stronger. So let's take the requirements at the beginning and the analysis model at the end and talk about how could we make that spreadsheet and that finite element model, how do we make that whole picture more model-based? So I'll throw an idea out there to you, and this is the one I want to dig into as an example on the webinar today, is let's say we could take that spreadsheet and we can actually break it down, right? So a list of requirements in an Excel file into chapters of related requirements, and take the requirements as they're listed maybe by the customer, and then break those down into sub-requirements and allocate out those smaller derived requirements from the main requirements till there's something meaningful and actionable in the design. But let's break it down and look at it as data. And then we can connect it. So things like that parameter that comes out of a requirement could be connected as input to our model, our simulation model, our analysis. So when we start to have pieces of our digital thread be model-based, we can start to connect them more richly than just say it, oh, well, they're related to each other, right? They're on the same thread. That's what I want to dig into for a minute. So let me take this example a little further, right? How do we get to model-based requirements? What does that even mean, right? So let's say we've got a document that is our set of requirements. Maybe it's coming from the customer like this. Maybe this is something that we write up. It doesn't really matter, but assuming we've got some requirements for the product up front, let's look at what that looks like. How do we break that down? How do we get to the nitty-gritty of it? So this environmental requirement, if I dug into my document, I would see it something like this example one I have here is the surface temperature of the device may not exceed 170 degrees Fahrenheit. Okay, great. I can find it within a document, but it becomes really interesting when I break that out into data. So I can capture this, and there are a number of requirements management tools and PLM tools out on the market that can do exactly what we're talking about here. Go through a document, grab pieces of that document, break it down and capture it as data, pull it out of the document, right? So you get the idea here is that it pulls it out and it gives it a unique ID, and it captures the number from the document so you can trace it back to what was sent to you originally, but it captures the detail, and if there's a parameter, it knows the value of that parameter, it knows the units of that parameter. So that's what we're doing to start to have a requirements model. Well, we also need to sort of combine those and understand how do they go together and how can we extend them. So let's say that our 7.4.4.3 requirement is captured, right? We might still need to break it down and allocate it and do things to manipulate it. That's what becomes our requirements model. So we've taken the information out of the document, we've modeled it as data, and then we've extended it so our model is even richer than the input that we had. Okay, now what do we do with that though? So this is where systems that we probably have in place today are useful, like PLM, like PDM, to starting to connect these models and how we're going to be able to share these models, right? So I gave that model sharing example earlier, but sharing models is not always necessarily about just one single model and how they get reused, but sometimes it's about passing the parameters and connecting back to data and trying not to duplicate it, but connecting things together. How does a requirements model get connected, right? So frequently what we see is that requirements models are used to do a breakdown of a system. Now, I'm not going to get into talking all about model-based systems engineering here. So that's something I'd plug in right here, but I'm not really showing. So MBSE is its own world within this. But let's say you've got requirements around the power module. Okay, well, those power module requirements get allocated to that part of the bill of material of your product where the power system is, right? And so you would connect those parts of the model of your product structure and the model of your requirements. Then you've got the actual physical models, right? So this product we're going to make that's got power requirements to it, it's probably got some mechanical design, it's got some electrical design. Those are a little different, but we probably connect those back to our bill of material so we know which motor to use and which battery to use and cooling fans and transformers and all those things. So we've got some connections there. From the mechanical model and the electrical model, we're going to use those as inputs to feed into that thermal simulation that we talked about earlier. So we look at how those CAD models, electrical and mechanical, feed into this behavioral or analysis model. Then we've got models potentially of our testing plans, our product validation plans, quality plans, things like that, where we say, okay, I've got a thermal simulation, but what is it I'm checking about it? Am I checking surface temperature? Do I need to put a couple of analysis models together to do that? Internal temperature, input volumes, what are the parameters, over what range, that kind of thing. At the end of the day, though, that model of our testing should connect back to our requirements, right? Because our test is going to validate that we met the requirement we said we would, and that's what closes the loop, right? So if we have models at all of these stages, sometimes shared, sometimes just connected, but when we tie them all together, we can close the loop on the whole process. Now, that looks interesting, right? I hope that looks interesting to everyone when they think, geez, if my requirements model had been parameterized and it truly was data, it wasn't just a set of requirements locked up in a document. If it was really data, that means that my validation test plan, its parameters could be driven off of the parameters and the requirements. If all of that was connected, right, and the CAD models connected to the BOM parts and the BOM parts connected to the requirements and the analysis models, if all this stuff was tied together, boy, I should be able to do some automations to check things, to validate that parameters are being met, to optimize the things I was talking about earlier with digital thread, right? So that's great doing that during product design and definition to start with, but I want to give everybody another sort of piece of food for thought here on how there can be tremendous value when you've got all of this connected and you're sharing all of these models. let's talk about change for a minute. So let's say that our product is out in the field being used, but somebody burns their hand on it. You can imagine how that process is going to go, right? They're using this drone or toy or heater or machine, whatever it is, and they put their hand on the place where that power module is, and they burn their hand. We're going to get an email. We're going to get a phone call. We're going to get something into customer service saying, hey, your product is dangerous. I don't like it. I hate it, whatever. That complaint email, let's say it comes with a picture, right? Hey, here's where I burned my hand, or here's the part that got hot, or whatever it is. That's going to start a process for us. If we capture that, right, we tie that to a problem report. Lots of companies have these processes in place, different business systems to capture, customer service requests, customer support, that kind of thing. That problem report is likely going to be in a system and tied to that email that came in. And the customer service rep that took the call and made the record in CRM or wherever they made it to start with is going to tie that to product ABC, right? It's not in this product line, it's in this product line. Here's where the problem is. We need to categorize and record these things so that we can sort out warranty claims and other issues and look at product improvements. Okay, that problem report then at some point should get reviewed and turned into an engineering change request. Right? Engineering looks at the product, looks at problems that come in over time, looks at cost issues, looks at lots of things and decides what to change about the product. All right, hey, we've got a problem report. It's on this component in the bill of material. It's this subassembly where the power is, where the batteries are heating things up. And we think we could improve this by making a change. Okay, that's all logical, I think. And engineering change requests, they get looked at, they get decided, do they go on hold, do they get moved ahead, that kind of thing. But frequently, when it's something urgent, like somebody burning themselves on your product, it's going to get turned into an engineering change order where you reference the change request, the investigation that was done, the decisions that were made about how we would resolve the problem and what the fix might look like and that kind of thing. And connected to what needs to be fixed in the bill of material. And then also we tie in what needs to be changed. Well, clearly we're going to have to change that power assembly, maybe the packaging on it, maybe the components that we use. We need a bigger cooling fan or something. Here's the part that's interesting that I want to highlight about all this model connection that we did on the previous slide. We should also be looking at the requirement, right? Because what changed here? If it was okay for the product to get to 170 degrees Fahrenheit, then that shouldn't be burning anybody. But the problem is that requirement that said, you can't exceed 170 Fahrenheit, that was actually wrong. You make something 170 Fahrenheit and you touch it for more than about 3 seconds, you're going to burn yourself. The right number is 140 Fahrenheit. But rather than penalize engineering for, hey, you did a bad product design, the truth of the matter is what we had is bad requirements. So we need to fix the requirement. That should also be part of the definition. And that model needs to be looked at also, right? So the engineering change order should attach all of these things, all the parts of our model of the product that are important to us. Once we've got all that, then the rest, we know how this works, right? We go do some engineering work. We've got all the right referenced information, all the right changes we need to make. We do the work, we generate the product revision, we re-release it, we go through the motions that our business goes through when we improve our product. But hopefully, when we see all of this connected thread back here, right? How do we get from the complaint down to a change in the requirement and a related change in the product? We are building up even more of our thread as we go through the process. So I want to kind of put a bow on all that, Derek. I want to come back to what did that do for us, right? Why, we talked about earlier, why do we need the digital thread? What does it do for us? And I'd like to talk about why do we need models? So a couple of things that I think we saw in what I described there about how you'd use models in the enterprise. First, to aid in decision-making through virtual experiments. So when we were developing the product initially and we were trying to validate what's the performance of the product, it's very useful to us then, okay? To predict behavior and facilitate understanding, right? So we could have checked also, was this going to burn somebody? We didn't in our first case. We just met the requirement and validated it. But could we have done that with the models? Absolutely, we could have. That's a value we could have had about predicting the future, right? And then the last thing is to time shift our problem solving, right? We didn't have this in my story here about how time sensitive this would be. I acted as if, all right, it's a customer complaint. We can change the product on our own speed as we need to. But the beauty of models is if we have them ready, they're at our disposal to do problem solving whenever we need to. If it's urgent, if it's proactive, whatever it may be, it can help us understand the situation, sometimes after the fact, sometimes ahead of the fact. But let me tie this back to the couple of values that we put on the digital thread to start with, because they're similar. They're not exactly the same, but they're similar, right? We talked about decision support, we talked about automation, we talked about forensics. And I think those are all still relevant, and model-based approaches on top of a digital thread can certainly help support those. The model-based benefits are a little different too. So I'm not trying to draw any grandiose conclusions here, but just to point out, there's benefits to both, and they are somewhat aligned, but they're also a little bit unique too. But it's a long way of answering your question, Derek, I think, about value.
Yeah, it's really good. In fact, it makes me start to think when you start looking at that full picture and how everything starts to tie back, your product actually, or the definition, that digital thread, it gets more intelligent and it starts to have more data in it. And I start to think about what's the future look like now when we start to apply, AI and those sort of things, as we know how our product's being used and we know what problems it has, and we start to record that in a system and we tie that information back to the tests and to the requirements. I mean, what's next? It really seems exciting on what can happen next as you start to capture this data.
Yeah.
I think actually that segues into kind of an area that I'd like to talk a little bit about in summary, is kind of how do you do it? What are the challenges? How do you go about getting to that point where you can start to realize this? Can I take a few minutes and go through a few of those?
Yeah, perfect.
So I think one of the things that we see can be a challenge for individuals is that balance of how do you do these things. You used the term grandiose, and I was thinking of that as well. Someone who's watching this sort of presentation for the first time may say, wow, that's awesome. We need to do that, and they may even be heading over to their file cabinet as we speak to rip up every paper drawing they have. Well, careful. And that's where, we start to talk about, well, how can you do this? And there's a balance to do it. And that balance is a balance between what we'll call passionate and what we'll call practical. Getting excited about this sort of technology is important. In fact, that's how new technologies and new approaches get adopted, is by people being excited. You want to be on the cutting edge, and you want to be moving forward. And so there is a place for passion in your decisions and in your future of your digital enterprise. You don't transform your business and transform the way you do business without having some level of passion. However, that needs to be balanced, and we need to balance that with the practical. So as I mentioned, someone may be running over to their file cabinet to rip up all of their old drawings, but hold on, is that really the right thing and the right time to do that? And so, at the end of the day, any business changes generally boil down to business value. We use the term ROI. While everything we talked about is exciting and interesting, there's probably parts of what we talked about that have some greater ROI. Sometimes we call that the low-hanging fruit, the things that we should do first and we should do early. And so you have to kind of balance this passion with, well, what is the right thing to do first? In different industries and in different sorts of products and different verticals, it may be that some of the cool stuff we talked about doesn't have a lot of business application. It's neat. It's what we might call a shiny object, but is it the right thing to focus on? So to really be practical and to think about that. And this last point I think is critical, which is, focus on adoption of these new processes. So that attendee that's out there ripping up his papers in his drawing file cabinet, is that really going to be able to be adopted by the community? Are some of those people that have been working on the shop floor for 35 years going to be able to function without that paper drawing? Probably not. Does that mean we don't go there? Well, no, it doesn't mean we don't go there, but it means that we have to think about that. And we have to think about how is this going to be adopted. And so balancing that practical with passion is what should lead to success. And that's really what our charge to those that are listening today would be, is that we want you to get excited about this sort of stuff. We want you to see what it can do today and how it lays a foundation for even doing pretty amazing things in the future. We want you to look at transforming your business and what technologies can help to do that. But we also want to say, let's make sure we're doing it in a way that's practical, that we're keeping the business value in focus, that we're not just doing something for the sake of doing it, but that we've thought through it and we've made sure that it's the right thing at the right time for our business, and that you're not forgetting the fact that people have to use this stuff. And so it has to be adopted by people. And sometimes keeping that in mind is what sets our priority and sets the order that we do things in when we start to talk about user adoption. So we're going to take just a few minutes to get some questions, but while we're getting to that point, let me just kind of summarize some of the things that we talked about today and that I hope you heard. And if you have any questions, go ahead and throw them in the chat window while I'm talking over the next few minutes, and then we'll Jonathan and myself will answer some of those questions. But we hope that as you came to this presentation today, that you learned a little bit more about the model-based enterprise. One of the things that I think is interesting from the first time I heard the term model-based is when I think of models, I think of CAD models. And that's, for a long time, that's the only thing I thought of. And I thought Jonathan did a nice job of explaining that a model is really a lot more than that. Certainly a CAD model is a model, but there's all kinds of other models as well that go into build that model-based. And then, I think as we went through some of those scenarios and we looked at that scenario, and some of the charts that Jonathan put up really helped us to see where this fits into PLM, and how PLM, since PLM is the storehouse of data, PLM really can be kind of the center of that model-based enterprise, and it can take that data out of our models and start to feed it into other systems. And I think that's pretty exciting. And the benefits that we start to see, the scenarios that Jonathan went over about feeding some of this model data into the CNC machine or the CMM machine, models that can serve multiple consumers, so a marketing model, a manufacturing model, an engineering model, but all coming from the same underlying 3D CAD source. That's some pretty exciting stuff. And so again, I hope that you saw some of the benefits that that can be had, and really what the definition of digital thread and how that works with model-based. I hope you were able to gather some of that information. So Julianne, I want to turn it back to you for just a minute, and hopefully there's a few questions. We've got a few minutes left that Jonathan and I could talk about.
Yeah, great. Yes, thanks, Jonathan and Derek. That was a great presentation. It actually helped me better understand the nature of model-based enterprise and how it works with the digital thread. We do have a couple questions in. I want to make sure you have a minute to answer them. So from Nick, we have, how is this digital thread achieved when working across different systems?
Yeah, that's a great question. And there's some easy answers and some not so easy answers to that. So one of the more straightforward answers is integration, right? I don't want to call it middleware because, frankly, usually middleware, it doesn't cut it. It's not enough, because to tie this kind of product data together, you're not just shuffling a value across from one system to another, but integration tools that understand a product model and can tie things together and know the events that matter when things need to be updated. That's one way that you can tie this digital thread together across systems. a looser way that sometimes is important is actually data sharing. This is tricky. So let me explain what I mean here. And for any of those folks in aerospace, automotive, defense, those kinds of industries, you'll probably identify with this quickly. But technical data packages, right? Shipping a technical data package out of your PDM or PLM system over to your customer or over to your supplier or someone else, and then letting them ingest that data and load it in. That is one way of sort of keeping that digital thread, but it's dangerous since you've duplicated the data. So you need strategies to make sure that if you are trying to maintain the thread that way through data sharing, that you don't run into problems caused by data duplication. So that's a more complex answer. And then there are other ways. Yeah, go ahead, Dirk.
I'm sorry, John. I was going to say I would concur with everything you said, and to Nick's point, I mean, the fact of the matter is all of the data doesn't exist in a single system. I mean, when you talk about the digital thread, even that scenario you went over, Jonathan, talked about, CRM being the starting point for a customer complaint. And so, someone shouldn't go down this path without understanding that there's going to be some need to get data from system to system, whether that's through duplication of data, let's hope we don't have to do that, or through integration. But yeah, we absolutely need to pull and push data from multiple systems in order to have a full fidelity digital thread.
Yeah, agreed.
Okay, great. We have another question from Eddie. What do you recommend as the first steps to move closer to MBE and automation?
Wow, Derek, you want to take a stab?
Let me start with that, and I'm gonna use a single word, or maybe it's two words. I don't know. Roadmap. Roadmap. I mean, you can't. There is, first of all, there's not a one size fits all. So it's not like, hey, you want to build a house. Here's how you build a house. No, because first of all, every industry is different, every company is different, and every company is at a different point in their maturity. And so we know, what the digital thread in the model-based enterprise needs to look like at the end, but oftentimes we don't know necessarily where to start because of the differences. And so it needs to start with the roadmap. And there's cases where people like Razorleaf can help build that roadmap. Frankly, a lot of times we need information from you. I mean, where you excel, where you don't excel. And so those are all inputs into that roadmap. But that's really where it starts, is to kind of step back and to say, what do I want to get to? Why do I want to get there? So that's the ROI question. And then where am I? So now I can identify my gaps. Now I can start to prioritize. Now I can start to plan. Anything else, Jonathan?
I think that's spot on. You mentioned something about knowing where you're strong and where you're weak and those sorts of things. It can help as part of that road mapping to really do an assessment. And sometimes that's an important part of it. Sometimes you don't. I mean, you just know, like, I'm weak here and I need to get there because of a customer or a supplier or something like that. But if you're not sure, part of the road mapping that can be helpful is assessing where you are today and trying to benchmark that. So that's another piece I think of, but I agree, spot on.
Great. All right, we got another question in from Rama. Do you have any examples of major companies that have implemented true end-to-end MBE successfully? And what tools besides PLM do you need to enable MBE? The two-pronged question.
The first part have implemented.
So do you have any examples of companies who have implemented end-to-end MBE? And then what tools besides PLM do you need to enable MBE?
Yeah, so no, I don't have any shining examples. And Derek, maybe you have some that we could say, look, here is the model company. I can tell you from some of the industry events that I go to that there are a lot of companies who in one division or another or one part of their business are doing it well. I think. I mean, they would probably agree. They're presenting at a conference showing off what they think is cool about what they've done. But I have not seen anybody, even amongst those who are kind of the leaders in this area, who have stood up and said, well, I've got it sorted out. here's what it is. You know, you're going to buy this software and you're going to do this to put it in place, and here are the systems you need, and that's the end of the story. The thread that I see, not to reuse thread, maybe theme is the better term, amongst those companies who are leading in this space is that they use leading tools for an area that is very important to them. So I'll give you an example. You know, they'll use a PLM system, whether it's, you know, one from Dassault or Siemens or Aris or whoever it is. They'll use it and maximize it to its ability, instead of taking a fully heterogeneous approach and a little best of breed here, best of breed there, best of breed there, best of breed there. So I see them maximizing the tool that they consider kind of their backbone and their platform, and then adding in components as they need them and integrating them. But they're all still doing that. They're all still integrating. A lot of times where I see that is the core PLM parts, right? The CAD management, ECAD, MCAD, bill of material, manufacturing planning, service planning, those kinds of things. And then they're integrating to a requirement system, or they're integrating to model-based systems engineering systems, or they're integrating off to enterprise asset management because they've got something that's a high value capital asset, and PLM is not great at doing maintenance, repair, and overhaul, and those kinds of things. So I'm probably rambling to answer the question at this point, but I don't see anybody who's got it sorted out fully. I don't see anybody doing it with a single system, not even listening to some of the ERP vendors that would say, hey, we've got modules for everything. I don't see anybody doing that. I see them tying things together and integrating, but trying to leverage kind of one focal system as a backbone. What was the other part of the question, Julian? Sorry.
I think you were touching on it. It was examples, and then what tools besides PLM do you need to enable MBE? Yeah.
Okay. Yeah, Derek, what would you add to that?
Yeah, I was just going to add to that you know, I think and I don't know that if this was the, you know, if this thought went into that question, but I think that we have to be careful, you know, full end-to-end MBE. What does that mean? Well, I guarantee you what it means today is not the same thing that it will mean even a couple months from today. The technology is always changing and always getting better, and your full end-to-end model-based enterprise should continue to change and grow as that technology changes and grows. You know, there will be software and machines and AI-based things that will be here in months or years that aren't here today, and you'll need to enhance and change and continue to grow that end-to-end model-based enterprise. So I think what we see companies doing, to the point that Jonathan made, is we see them focusing on the parts of that model-based enterprise that are most important and have the most value for them today. And then when that's in place, they move on to the next thing. And oh, by the way, business changed, industry changed. You know, you think of a company maybe 2 years ago that sold products at Walmart, and they're starting to look at now selling their products as a service. Well, your model-based definition now starts to need to include other things, different things than when you were just selling a consumable product. So I think, you know, you have to kind of keep that in mind as well. I don't know that you'll ever get to somebody that says, we're done, because I don't think you're ever done.
I think that's right, Derek. I'd layer one more thing on top of it is, if you thought you could buy that super tool that would let you do it all, you would need to buy it today and put it in place today, because 3 years from now, the software landscape will look different. The technology landscape will look different. So it's almost a fool's errand to try and put one system in place to do it all, because you know there's going to be a new system, a better way of doing X or Y tomorrow. So planning to be heterogeneous out of the gate is probably the right thing.
Yeah, and Jonathan, I want to just, I know we're talking a long time about this, but I think this is an important point. I do want to caution that what you just said does not mean that you don't do anything. You know, sometimes people hear phrases like that, like, if, well, whatever you put in place today, you'll probably need to relook at it in a couple of years. And they're like, all right, well, then we'll just wait. No, that's not the answer. Because we do know that we're going to a direction that requires data. It requires that data to be digitalized. It requires that data to be accessible. So we've got to start putting that in there. If you can't start putting the foundation in place, you can never get there. And there's still tons that you can do today, even though we don't know what the future looks like. So the fact that you should be prepared for frequent changes and updates and enhancements doesn't mean that you don't start today. Because if you don't start today, what do they say? When's the best time to plant a tree? 20 years ago. When's the second best time? Today. So you probably haven't been capturing this data for 20 years. Okay, so let's start today.
Okay, we got a couple more questions, guys, before we got like 3 minutes left, so I want to be respectful of everyone's time. Mayan asks, there's an MBE Maturity Index to assess current state and target state. Could this be used to support roadmap development?
Absolutely, absolutely. That index is really very good. It's a scale of, I forget, 0 to 5, 0 to 6. But it's very good at indicating where you are, where you stand today. And if the organization is honest with itself about where you feel like you need to be, and you can tie that to business objectives, that's another big if, that's a great support, right? That's a great foundation for putting a roadmap together. So it's absolutely helpful.
Okay.
I'd like to point out that on, in the slide that's up now, we do have a digital thread assessment tool that can kind of help with some of that as well. So that MBE Maturity Index is great. Take a look at our tool as well. That'll help with some of that also.
Yeah, and I just want to mention, Nick mentioned that let's not forget on that last question, let's not forget that the people in the org changed to support all these things that you guys are talking about. So I think
Good
that's
point.
something,
Yep.
yeah, really, really tough stuff to do. But
I think it was
okay.
Derek brought that up in that adoption point, and that is absolutely true, right? You have to figure out how the organization adopts this stuff. It's not just tech.
Right. Okay, another question from Gary. What application is base CAD application for your intended process? And he spelled CAD, C-A-D-D. I've seen this type of application as part of CATIA in the automotive industry years ago. Also, it seems like STEP AP 214 was created to export share the type of information presented here. I don't know if it's more of a comment or.
Yeah, can you just repeat the first part of the question?
What application is base CAD application for your intended process?
Is base CAD, B-A-S-E?
Yeah, B-A-S-E, yeah.
Base CAD. So I'm not sure if I'm following the question. That might need a follow-up, but I think the CAD that you're using is kind of the basis of a lot of this modeling. Really depends on your industry, because some of the examples that I used talking about power and temperature and things like that really have no relevance to some industries. So it can be very industry dependent, and like I was mentioning at the beginning about the values of digital thread, different industries see different values. If you're selling a product as a service, it looks very different than if you're selling it as a consumable or as a piece of large capital equipment or whatever it might be. So I'm probably not answering the question because I don't fully understand it, but I know it's going to vary by industry and what you're trying to accomplish.
So Gary, maybe we could follow up with you after this with an email to further understand that. We have one more last question. It's 2 o'clock, but I want to get Michael's question in. As design model and as build model can be for each next product different. Also, the quality part of the model is a feedback that, in my opinion, should be already taken into the loop. Any suggestions how to enable the safe and easy transfer of the information on all the steps involving different makers and sub-suppliers?
It sounds tricky, I'll tell you that. I can't say I followed the question entirely, but I agree with the intent of it about different as designed and different as built. I mean, it sounds like you're talking about something that's pretty, high capital equipment that's going to have that's going to be worth that kind of investment in design to be unique to every product rolling off the line. But once you have that actually gets us into a topic we didn't talk about today, but digital twin, right? And building digital twins out of your digital thread and making your digital twins as model based as possible to make them useful to you down the road. So I don't know quite how to address the specific question, but I think it's bringing up a really important point to think about when you're thinking about your digital thread.
Okay, great. I think that is all we have time for today. So this was very, very great. Thank you everyone for your participation. Some great questions today. I would recommend if you have anything or specific that you'd like to follow up with Derek and Jonathan, feel free to send me an email. Mayan's asking, do we plan to do a future webinar on digital twins? And I think the answer to that is yes. I think we were talking about that, right, Jonathan?
Yep.
Yep. So stay tuned, because we do have, as we look at this last slide here, we do have some plans for a 4th webinar in this series that will likely include the topic of digital twins. So that'll be probably scheduled early Q2. We'll watch for that. But, I think,
before you wrap up, I would just, there's a couple of people that asked questions that maybe we didn't fully understand completely.
Yeah.
If you folks, if you wouldn't mind just reaching out to us via email so that we could have a conversation, I'd love to follow up on some of those.
Great. Okay, so just to close, what's next? If as Jonathan said, Derek and Jonathan are more than willing to have a conversation. I think a lot of times people don't know where to start. So if you don't have if you're confused about what to do next, give us a call. We're here to help. We also have a self-diagnosis assessment where you can get online and do your own, answer some questions about our digital thread. And you can kind of see where you land in the terms of, where your organization lands for maturity around how you responded to those questions. So if you feel like you have about 10 minutes, you can check that out. And then we'll be following up with some technical tips in email. And if you haven't yet signed up for our newsletter, we just suggest that you do that, because we put out a lot of good content on our blog and summarize that in our bi-monthly newsletter. And as I mentioned before, we have a 4th webinar scheduled early Q2, most likely around digital twin, and we hope to see you there. With that, I'm going to thank Jonathan and Derek for your presentations today. It was very interesting and very informative. And I thank everyone today for participating, and have a good afternoon.